we're talking about, we were just talking about attenuation, but that brings me to another topic, a pretty important topic when it comes to broadcast engineering, and that is audio mixers. Now, along with your television, you always have a certain amount of audio, and so the audio is part of your system. If you have real good video and you don't have good audio, you just don't have a really usable product, and vice versa. And lots of people that are videographers tend to ignore the audio, and so they have all this beautiful video and then they have audio that's absolutely terrible. And there's lots of mistakes people make from an engineering standpoint where your audio is really bad. And so one thing you have to realize is, you know, if you're actually doing like I am now, I've got a dynamic microphone on a pedestal here, and that's working pretty good for me. But if I was in a group setting and there was a lot more ambient noise, I would consider using a lavalier mic. And so that's one thing to consider. And you have all these different mics, like you have a dynamic mic which doesn't require any batteries, and you have condenser mics that require batteries for them to work. And usually that battery is an integral part of your microphone. But in studio production situations, what you have is something called phantom power, which is a 45 volt source or thereabouts that drives your microphone so it has power to work. And so in most situations like that, you're actually getting power from your audio mixer board. Now, audio mixer boards come in all different shapes and sizes, but basically the function of an audio mixer board is to take inputs from many microphones, at least 2 or 3 or 4, and other audio sources like CD roll-in, remote feeds that we're getting off of a transmission, a telos signal off a telos device to be feeding a telephone information in. And there's a numerous amount of audio signals that can be fed into an audio mixer. And audio mixers are usually defined by the number of channels they have. You could have an 8-channel audio mixer, which would be really good for small remote shoots, and then you could have a 12-channel, and you go up to 24-channel and 36-channel and so forth. And this determines the size of the number of inputs that you could have going into your audio mixer. However, there's a lot more to an audio mixer than just the channel ends. When you look at an audio mixer, especially, you also have to determine what the function of the mixer is. And there's 2 basic categories of function for an audio mixer. One category is for reinforcement. The other category is for production. A reinforcement audio mixer is designed to reinforce the signals of the audio in a room, like you're in a PA situation and you have a large room like an auditorium or a symphony hall or someplace where you need the audio reinforced. And so a reinforcement mixer is designed to work in a situation where you have a lot of people in a big room, and of course the people in the back can't hear without speakers mounted around them or somewhere in the room to reinforce what the person is saying, you know, whoever's talking or the music or whatever. That's a reinforcement mixer. The other mixer would be a production mixer. You have a production mixer that would be used in a recording studio. It has one set of characteristics. You have a production mixer that's used in a television studio and a broadcast television studio. That has another set of characteristics. And so even though you can interchange these mixers to a certain degree, it's always best to determine what your function is. Is it going to be for reinforcement? Is it going to be for broadcast? Is it going to be for sound mastering? When you determine what mixer you're going to buy. But the basic of mixers is you'll have a bunch of channels, a number of channels with mic inputs, line inputs, and some of them even take other inputs like digital inputs or fiber inputs to the mixer. And these are all fed into the back of your mixer. And each channel has an input, like input 1 is mic 1, input 2 is mic 2, input 3 is mic 3, and so on. And you go on down the road and on the row of your inputs, and then one of them might be CD roll-in, remote video roll-in, which has an audio component, feed from network, a feed from telephone or whatever. All these are feeding into your mixer. But let's take a look at one channel. One channel is going to have a slider pot, and it slides, up or down. And when you have it all the way down or all the way toward you, then the audio is cut off for that. And then you'll actually take a look at the pot when you slide it up, and the audio will get higher and higher. There's also something at the very top of your mic channel called a trim pot. And a trim pot is what you use to adjust the actual overall gain for that channel. And so let's just go up the actual row, or up from the bottom to the top of your individual mic channel. You've got your slider pot. Above that, you'll have a mute button. The mute button turns that channel off or on. Now the other button there would be the pan pot. Now pan control would assign the output of that channel to either the right or the left, or some midpoint in between. Let's say you're actually micing a symphony hall, and you have mics all over the orchestra, and you have, say, a mic near the drums. Okay, when you go to set the pan pot for the mic for the drums, that position of that pan pot should sort of relate to the position of the drums from the right to the left. And so if the drums are on the left, you want to put your pan pot to the left. And so you have some horns over to the right, and you have a mic by your horns. The pan pot would go to the right. And so basically you're reinstituting the audio position of your microphones into your audio circuitry, so that when the listener is listening in stereo, then the relationship of all the things that are in the symphony orchestra, all the instruments that are in the symphony orchestra, are in the same relationship that a normal person sitting in the front row would hear. So when something comes from the left, you would hear it on the left. When something comes on the right, you would hear it on the right. Now that is a rule that sort of revolves around stereo production. You don't have to follow it. Lots of people don't. But in general, you want to use your pan pot to reinstitute the stereo positioning of whatever you're mixing. Now, lots of times people take a lot of work with those pan pots, and they'll actually greatly accentuate them so you have a lot more stereo separation. They'll actually put them all in the middle so the program's all pure monophonic. But the pan pot is basically what determines the position, right or left, of your mic when you actually play it back in reproduction or reinforcement, or if you're mastering and you decide you want to put the drums over here, that's where you put them. But you don't have to follow that. A lot of audio people don't believe in that, and they'll just put it wherever they mix it, where it sounds best. You listen to the early Beatles recording, and they would have very hard separation of the right and left channel, and you'd have the vocal on the far right and the drums over on the far left. And that was something they decided to do, something sort of avant-garde at that time, and that was a typical early Beatles recording. There's a lot of engineers that say we're just going to mix it all audio and play safe. There's also some engineers that when they're recording a live event, they'll do something like mono-compatible microphones, where they'll put one set of microphones in the middle of the room, or in the middle of where it's going to be picking up the orchestra or whatever, and they will to have mono compatibility, where people listening on a mono receiver would hear good sound, as well as people listening in stereo. They have the two mics and they cross them. The mic on the left faces right, the mic on the right faces left, and then that allows the feed to be both compatible in stereo and mono. There's an issue when you actually take signals and you combine them back into mono. Like if you hear something great in stereo, it's absolutely beautiful. It's got a lot of separation, but then when you combine it back into mono, it has cancellation, and so the phase is out from the right to the left, and when the phase is out from right to left, when you combine the signals back again together, what it does is cancels, and you can actually have a situation where you hear beautiful stereo and someone listens on a mono monitor, mono radio or something, and nothing's there. You can actually do it, if you want to a point where people can hear in stereo, but they can't hear the mono signal. It goes to nothing because you have direct cancellation. So that's important. So that's sort of the little topics on the on the pan pot. You go above the pan pot, most of them have some sends where you can actually have separate outputs, submixes, and sends that go out of your mixer, and so you can actually dedicate that channel to go to separate outputs on the back of the mixer. If you want to feed a specific thing for a specific purpose, you can use a send. You can also feed it to submixers. Like I've been talking about your main output stereo. You have a mono output of your mixer board, a stereo right-left output of your mixer board. You have submix that's coming out of the right side of your mixer board. And then what you'll have is sends where you can actually take that channel and send it to another area. And also there's little push buttons on by your slider pot usually that will actually send that signal from that channel to your sends, or to right left, or to mono. And those little push buttons have to be turned on for that signal to leave that channel to go to your output section. And you go on up from your sends, then you go to your equalizer. Usually most of these boards have like a 3 stages of equalization, maybe 4. Some of them have a low frequency pot, little turn pot, and it may even be variable in range, and so you can adjust the low frequencies, then you adjust the mid frequencies, and you adjust the high frequencies to sort of sweeten the audio that's coming out of that particular channel. Okay, and that's one channel. And you take all the channels from left to right, and they all usually have the same functionality, where you can do your panning, you can do your sweetening with your adjusting your frequencies, your frequency response, and adjusting the treble, the bass, and the mid-range coming out of that channel. But then you get over to the right side of it, of the mixer. You might have an effects channel, something to put in echoes or whatever effects you want to add in, so you can loop your signals through your effects. You can then also have your submix groups, and like might be A, B, C, or 1, 2, 3, and those are feeding to specific outputs on the back of your mixer. And those outputs can be taken at those points and used for determined purposes. And then you have your and what would a purpose be for a submix? Well, there's a term we use called mix minus. Okay, let's say you have a bunch of people, or you're listening on a telephone, or you have someone talking in a reinforcement situation where the audio is being reinforced in the room. You want to avoid feedback, and so let's say you have someone that has a speaker right in front of them. They're speaking at an event, and they have a speaker, and that speaker is feeding them not program, but audio from the mixer. But they have a microphone right next to them. Well, you don't want the audio from that speaker going to that microphone causing feedback. And so for that person that's sitting at a location with a microphone right next to a speaker, you would do something called a mix minus. And what a mix minus would be in that case would be the entire mix that's coming off the board minus the microphone that they are talking into. So there's no direct feedback loop from that microphone to that signal. That's a mix minus. Lots of times when you're sending people a telephone signal and they're talking to you over the telephone, you want to minus them from what they hear. They need to hear everybody else talking, but they don't need to hear themselves. That's a mix minus. And so sometimes you may have an IFB system. An IFB system is when there's a talent sitting in the studio and they have a little headphone and they're listening to remote signal from someone at the other end of a conversation, or maybe the director is giving them information in their ear. Well, of course, they don't need to hear themselves talk. It can be very, very distracting. And also, if they're talking and then it goes out on a satellite and then comes back again, what happens is there's a substantial delay. And so then they hear themselves on a delay, which can confuse them to the point where they can't talk. And so we do a mix minus on them, feeding to the IFB, where they hear what they need to hear, but they don't hear themselves or something that would confuse them. And so that's another function of mix minus running through your mixer board. And you know what I'm thinking of when you have like a talent sitting in a studio and there's there's a person that's called in on a telephone. The talent needs to hear the telephone, okay? But the talent doesn't need to hear everything else going on in the audio chain. And so then they can actually hear the telephone conversation, talk to the person on the telephone. The telephone person doesn't need to hear themselves. They just need to hear the person that's talking to them. And so you do a mix minus settings on your mixer board to prevent them from hearing themselves, but they can hear each other. And so there's a lot to that, setting up your little push buttons and your groups where you can do a mix minus where the right signals get to the right place for the right situation. And so, and then you get over to the far right of the mixer, you'll see your groups, 1, 2, 3, and then you'll see your stereo out, and then you'll see your mono out. And those have to be configured to your infrastructure to where it all can be utilized to do the various functions you need to do. If you need to have someone talking to you on a telos, that's a telephone interface device, then it can be fed into your mixer, and then the signal can be processed correctly. Also, you may have a routing switcher in your infrastructure, and your routing switcher may be feeding a lot of your input of your mixer board, so you've got to then route, then mix. And so that's a lot of work to get that planned out where it works correctly in broadcast engineering. And so that covers audio mixer boards. And you want to feed your mics into a small mixer board, and then you want to actually have it going into your camera. You want to take it from line level to mic level using an attenuator and feed it into your camera if your camera doesn't take line level. And make sure that you can get a good signal when you're listening to your headphones, on your mixer board, on your camera, that you're getting good sound going into the camera. Sometimes it's good to get an external audio recorder like an Nagra, or there's another number of different brands that you can use to record audio and then sync it back to your video in post.